Well, my name is Patroklos Papapetrou, and I'm from Greece. And as you already know, I'm going to discuss about technical debt, about some code quality factors, and there will be a short live demo about how you can manage and track code quality with SonarQube. So some things about me. I started working with SonarQube 4 years ago. Active member of both user and development mailing lists. And recently, actually 6 months ago, I was a co-author of SonarQube in Action book published by Manning. And of course, I'm a clean code evangelist and agile mind. And so here I am talking about some code quality aspects and technical debt. So here's a short agenda of what we're going to discuss during the next 45 minutes. So the first time I would like to explain is what is actually code quality. And I would like you to help me on that. So you have 1 minute to review my code. Okay, and then I'll ask a couple of guys to give me your insights about the code. Don't be gentle. So, what do you think? Sorry? Ugly. Okay. No code conventions. Okay. So, how many times did you think, what the fuck is he doing? None? About 10. Okay. But you? How many times? Even more. Even more. Okay. So, let's say we have an average of 10 what the fuck per minute. So we have a measurement. Okay. So my code quality is 10 what the fuck per minute. Okay. So that's only a joke. You can find this graph in internet on the Google many times. So my point is that actually there's no good definition about code quality. If you search on the internet, you will find several definitions about quality in software in general, but code quality is something really abstract. So I tried to invent, to come to some, let's say, term. So from my point of view, quality is just an indicator of how quickly developers, can add business value to a system. Okay, so if you find yourself working only on bug fixing or refactoring existing code, but not producing any real value in the system, then something must be wrong with the quality of your system. Okay, so now that you know about code quality, let's explain why it's important to measure. Okay, source code, it's the heart of every system. Forget about tools, forget about methodologies, forget about practices. It doesn't matter if you are an agile shop, or you're doing Scrum, XP, or you are still stuck with waterfall. Your code is the heart. So as you try to be fit and work with your body and your heart, and do some checks and exams, so it's the same with your source code in software. So that's the first thing you have to keep in mind. If your source code is in a good shape, then everything will run smoothly with your development environment. The next one is that I think that developers are actually very unlucky people, because for our whole professional career, we mostly write code for legacy systems. Okay, so to be honest, how many of you are working on a system that is it's only 3 months long living? I mean, a new project. How many of you are working on a new project that is only 3 months age? No one. So how many of you are working with legacy systems? Most of you. Okay, that's the case. So to make it even more general, I think that a legacy system, a system that has at least one customer, it has at least one deployment in one installation, it's called legacy. Okay, and that's because from now on, from that point on, every new feature you have to add must be compatible and must take care of previous features, existing code. So you have to deal with existing code, good or bad, you have to cope with and to be very gentle with this code. So I think that developers are only working with legacy code, and legacy code is really, I have been working in a company that we have a system that was created 20 years ago, before I even started working as a professional. So I can see thousands of lines of crappy code. Okay, so that's not only in my case, but in several cases. The next one is that, okay, I doubt if any one of you is not a lazy developer, okay, and not only lazy, but lazy monkey, and I explain why. Because we have two attributes to developers. We don't want to do a lot of job. We're going to be productive, but in less time, and we act like monkeys because we want to imitate other people. Okay, so we want to copy and paste their code because we believe it's right, and we will save us from a lot of time. So that's our two bad habits of developers, but create a lot of bad code quality. And to give you another example, do you know the broken window theory? Okay, that's a short explanation. That was a theory that was, let's say, introduced back in the 80s by some social scientists, that they were wanted to explain to the police that if something is broken and you don't fix it, then it is much probable that you will have some more problems. For instance, if you have a building with some broken windows and nobody is going to fix them, then it's much probable that some guys will throw some stones and break some more windows, or even worse, they break the door and lit some fires then and live in the same building. So it's the same exactly in your source code. If you find ugly code, it is much more probable that you are going to live on this and build on this ugly code, so produce more ugly and crappy code. Okay. So now that we know how and why it's good to measure, let's say when it's the right time to measure. So I think that the right time is from project day 0. Before starting working on a project, you have to define clear quality requirements and engage all developers to live with this and cope with these quality standards. So this has to be done from the first day of the project and has to be done continuously. I mean, quality is not something that you have to do only on a ad hoc basis. Every time, every day, every single commit should be aligned to some quality standards. So from the first day of the project and continuously, you have to deal with quality. And it's better not to act like fire station like post actions, but it's better to take prevention, to take some actions before some bad things happen to your code. So that's nice and well when we are working on startup projects, clean greenfield projects, but what will happen if you are working a legacy project? Okay, so my suggestion is that do the same things from the first day that you realize that you have to deal with quality. Okay, so said that now it's the day 0 of my project, so I will start working with quality like this from now on. So new code is going to be aligned with some quality standards that I have set and we have agreed as a team. So the last thing is that not everything is, when we're talking about quality, it's really bad. Okay, we have to prioritize some flows and see what it is really important has to be fixed at once, or we can live with it for the next couple of weeks, or we can postpone this fix to the next iteration. So we have to prioritize and plan these things to be fixed in a specific timeline. Okay, now we're going to the meat of the problem. What we should measure. There are hundreds, several of different metrics that deal with different factors in quality. So, in sometimes when I ask some teams, what quality numbers are you measuring? They tell me, for instance, we want to know how many unit tests we have. Okay, so how many tests you have? Only we have 100 tests. So this doesn't say anything. You have 100 tests in how many lines of code? Of 1 million, 1,000, or whatever. So abstract numbers are in most cases useless. I know that some years ago, many developers were paid by the lines of code that they were writing. Okay, so I don't think that any company actually still does the same. But abstract numbers doesn't provide any actual information. Okay, another example: if you have 50 lines of duplicated code, again, out of how many? Out of 100 or out of 1 million? So you can see the difference between abstract numbers and density. So even if you try to measure some things in density and some real values, it's not always helpful to know only one number. You need to know how do you evolve through time. Okay, so you have to know how do you improve quality or you decrease quality through time. So my suggestion is try to focus on some quality metrics that you define and try to measure them in standard basis. So now comes the real question: which metrics are most appropriate for you? Testing, coverage, duplications, complexity, or whatever. So here comes the 7 deadly sins of developers, or alternatively, what we call the 7 axes of quality. So there are 7, let's say, categories, and they call 7 axes. So I don't know if your English as well, but what do you think that the word axis actually mean? Doesn't mean, of course, that, although you can think that we have some bad smell of code and we can eliminate them using axis perfume. So you can use this kind of axis to kill developers that have created this code. Apparently, I'm not talking either of these kind of axes. I'm talking about the plural word of English word axis. Okay, so we have 7 different axes, and let's name them quickly. We have design, complexity, documentation, potential bugs, unit tests, coding rules, and duplications. So let me elaborate a little more about that. Complexity is mostly focused on cyclomatic complexity. Documentation is not about documenting some user or administration guides. Okay, it's about documenting your code, writing Java doc, like writing inline comments whenever it is needed. Okay. Design, it's about the architecture of our system, how well the dependencies between the packages, the modules, modularity, maintainability, things like that. Unit testing, it's about coverage. So I was listening to the previous talks that were about unit testing and integration testing. It was really cool because there are 2 different things, and SonarQube, as we're going to see, manage them as 2 different entities. So everything that is not unit testing falls to the category of integration testing. So if you have in-container testing, database testing, UI testing, everything that is not unit tests is an integration test. Okay, so we need to have coverage, or at least if we try to write some tests for both categories, we need to know how much of our code is actually covered by these tests. Then we have 2 categories, but they come to pairs. We have coding rules and potential bugs. Usually, a potential bug, or a bug, if it's certain, comes when we break a coding rule. I assume that some of you have already worked with PMD, find bugs, check style. These are very popular static analysis tools, but they have some set of rules. Okay, so in SonarQube, when one rule is broken, then we have some issues. These issues can be handled like potential bugs or certain bugs or inefficiencies in performance or future programming errors. We have several different categories. And the last one, which is my favorite, is duplications. It's my favorite not because it's the most important, because whenever you copy and paste code, you just copy and paste all the other 6 problematic areas. And it's, like I told you, it's the favorite action of developers. Lazy monkeys. We would like to do most of our work quickly without new thinking. So these are the 7 quality factors, and all of them, if we combine them in some way, we create a metric which is called technical debt. Technical debt is somehow a buzzword lately because I think it's easily to understand not only by technical people. Non-technical managers don't care about duplications, about complexity, how many lines of code have you write to test your system. They only care about, they would like to see some numbers, but clear numbers. So technical debt is expressed as only one number, and it's expressed as a number that you can understand. It's working days. So if you know that your system, the effort to create the highest level of quality in your system is 40 working days, is something that managers can understand. And even better, you can multiply these working days with your local currency and have the same amount, the same metric expressed in currency, in euros, in dollars, or wherever is your currency. Okay, so that's a very great metric. And if my manager wants to see something about quality and doesn't understand, of course, the rest of the factors, that's the one that I would like to give him. So that's the definition of technical debt by Steve McConnell, which is the author of Code Complete. I will read it loudly and then elaborate a little more. If debt grows large enough, eventually the company will spend more on servicing its debt than it invests in increasing the value of its other assets. This is a general definition, not only about technical debt, but in the context of software engineering, it means that if you find yourself spending time eliminating this debt, then you have a serious problem. So let's see. Let's give you another example about how technical debt is created. How many of you do you like to cook? A few. Okay, but you all like to eat. Okay, that's great. So let's say that it is Friday night and you have invited some friends at your place and you decided to prepare some light dinner. So you go to the kitchen, prepare some food, but because you want to hang out with your friends, you don't really care about cleaning up the kitchen. Okay, so you leave all the leftovers in a mess. Then the next morning, Saturday morning, you're going to prepare some breakfast. You find some place from the dishes and the pots you have left from last night, and you prepare some breakfast. But again, you are too lazy to clean it up. Try to do that in the same kitchen for the weekend or the whole week. Okay. At the end, you will find something like that in the kitchen, apparently. Okay. So the same analogy is about source code. Imagine that you're writing a new feature. Okay. It is most probable that you might, take some code from another class that is working, do some tests to evaluate how things are working in your code, but you forget to move all these bad habits during the implementation. You forget to eliminate duplications, you forget to write tests, you forget to refactor any large classes. All these things that you've forgotten to do, you don't clean up your code. Okay, you don't clean up the kitchen. So the next guy that is going to use your code might be you also. Okay, will find a messy and crappy code. And eventually, if you see a code like this, then you won't be able to add and maintain this code. So what's the solution? Just blow up the kitchen and buy a new kitchen. Okay, that means destroy your system. So the idea is that before you find yourself committing or pushing some code in the repository, step back a second and think how you can improve your code. Have you write tests? Okay. Can you refactor the code to be more readable and more maintainable? Just do it. So clean up the kitchen. So the next guy that's going to use it, it will find it as best as it can be. Okay. So you want to end up and feel like this is your source code every time you are in a system. My experience has shown that I have been in that position. I'm working on a legacy project. We have some classes that there are more than 2,000 lines of code, no unit tests, nested ifs, complex code, variables with names that has nothing to do with the domain problem. So I can figure out what's the idea of cooking in that kind of kitchen. So, but so far you think that technical debt is evil, okay? But in some cases, technical debt is good. Let me explain in which cases. So imagine that this is the starting point of your project, and through time you have created some technical debt, new duplications, complex code, no tests. Okay, and at this point here, you start working on a new feature. So until you finish the feature, you might create some debt as well. It's okay to live with that debt as soon as you are still implementing the feature. It's like cooking. You don't wash every dish that you are using in your meal. Okay, you finish your job, you finish the meal, and afterwards you do all the cleanup. So it's the same in technical debt. As long as you're writing code, it's good to have some technical debt. But as soon as you finish and you commit your code right here, then this green line becomes red line. Okay, it becomes bad technical debt. So my suggestion is that you have at least, at most, 1 day before you commit your code to improve the technical debt. Okay, and reduce it and place it at the standard level that you have set for your development team. So it's not always bad. Sometimes it's good. Okay, and remember that you can have zero technical debt. You can have an absolute perfect quality code. At least you have to set the lowest and the maximum number of technical debt you accept for your system, and try to be between these two lines. So let's see what SonarQube is. SonarQube is open source and free quality platform. It's not just static analysis tool, although it is integrated with some tools that I already mentioned. It's free and open source. You can download it, you can install it, you can modify it because it's open source. Everything, you don't have to pay anything. The core concept is that you can have snapshots of your quality in a specific time. So every time you analyze your code against SonarQube, SonarQube creates a new snapshot. So you can have different snapshots of the quality of your system in different moments through time. And because of that, because SonarQube keeps historical data of all these snapshots, it can provide you and give you some indicators of how well or bad you'll be doing in code quality the last period, or even better, if you keep doing the same thing, how well you are going, how much will the system improved in the next period, during the next months or the next weeks. And of course, SonarQube can compute and provide information about all the metrics that are associated with the 7 deadly sins we've seen before, about design, complexity, documentation, testing, everything. So how it works, SonarQube is not a tool for building projects. It's not a build tool. We have Maven, we have Gradle, we have and we have several different build tools. SonarQube is not a build tool. It doesn't compile and build your project. You feed SonarQube with source code and with binary files, and then it analyzes them with several analyzers, several plugins, and computes a bunch of different metrics. Okay, we're going to see later on which are these metrics. All these metrics and the results are associated with its snapshot. Okay, so every time you analyze a system, you get a snapshot with several metrics, and these are persisted in the database. And of course, all these are represented in a very flexible and very convenient web application through some dashboards. So the difference, one of the main differences of using SonarQube against some analysis tools like PMD and FindBug is that in FindBugs, for example, you run an analysis. FindBugs produces an HTML file. So if you want to share it with other developers, you just email it, and you all have the same HTML. So you send the reports to developers. Now, in our case, you send developers to the reports. So you say, hey, here is your reports in the dashboard. Type this URL in your browser, and you can see them. Okay. And not only that, you can see some historical data, which you can do that in other cases. So SonarQube I think it's more than 5 years alive. It was initially designed only for Java and Maven projects, but a lot of things has changed from that that period. So today it's independent from any build system. You can run everything with SonarQube and supports more than 20 languages. These are open source plugins and these are commercial. As you can see, most of the more popular languages are available through plugins. So you can download plugins and analyze projects with other source code, not in Java, and have exactly the same metrics as is in Java. And SonarQube is not only for developers. Apparently, developers can benefit from that. They can see how they can improve their code if they are writing crappy code or readable code. But other team members can also take advantage of SonarQube. For instance, testers and QA staff can see some information about unit testing. So, and I assume that testers are limited resources, don't have enough time to test the whole system every time to do a regression test. So they can focus on the modules or the components that are not adequately tested by unit tests. So they can focus on these systems. SonarQube can give you this information to focus only on the components that are not tested well. Architects, if there's this kind of role, or let's say senior developers or designers, can see also that the design was broken or the complexity has increased, the architecture is still forming well. All this stuff is within SonarQube. And finally, like I said, managers that care only about numbers and numbers that can easily understand currency or working days can take advantage of SonarQube and see only the technical debt information. So all of the team can have access to the same metrics, but in different perspectives. Okay, not only developers. And to be honest, everyone should care about quality, not only developers, but developers are the only responsible for acting and improving the quality of the system. So, some star features about SonarQube. Just to have some slides, I'm going to give you a live demo in a couple of minutes. Like I said, we have some dashboards. You have two kinds of dashboards in SonarQube. We have global dashboards and project dashboards. Global dashboards are used, like this one, are used to give you an overall information about some or all the projects that are hosted in SonarQube. You can have these different representations of the same projects as a list, as a pie, as a tree view, or you can display the same information with different options. Project dashboards are more give you some information about the project itself, and as we're going to see, they display all the 7 different axes of quality with widgets. Now we have also some historical data and different widgets that you can extend how the code has been evolved. As you can see, here is something, a line of code, that how many lines of code have been added through time, and different metrics compared to each other in different dates. So if you know the history of your project, you can take some serious decisions about how you can move from now on. Another key feature that is really cool is what is called differential views. You can compare today's snapshot with something in the past for the same project. So you can see exactly which numbers are getting better or worse. Okay, I'm going to explain that in 2 minutes. And finally, we have the components drill down view, which is, let's say, a more detailed explanation of where exactly are the problems in your code. Because project dashboards are okay, we can have an overview, a bird's eye view of the an upper level of our project, but okay, that's only a good start. We need to know the exact place of the problematic areas in your code. So drill down views are exactly what you need. You can drill down, as we're going to see, to the source code and find exactly the line of code that has some issues. So the last one is a term that was recently introduced in SonarQube. There are quality gates. You can define a set of thresholds, of quality thresholds, so that every time that one or more threshold is reached in your code, you can get notified by several different ways, and you are able to know that something is not going well in your project. So for instance, when the coverage on new code is less than 80%, I'm going to get notified an alert that's an error. Okay, you can have as many quality gates as you have for different projects, for different languages. It's really very customizable. So I'm going to shift back to the real application. I think it's looking good. That's the global dashboard. I'm not going to expand more about that. I'm going to give you some insights about a project dashboard. As you can see, every, let's say, block of information, it is called a widget, and we have one widget for every quality access. For example, here we have some metrics about documentation, and here we have some metrics about test coverage, about design, complexity, and down here about duplications. Okay, you can click on any of these metrics, and then this will navigate you to the drill down view I just talked a couple of minutes ago. So clicking on issues, an issue is in SonarQube a broken coding rule. Okay, so you can dive from the package level to the source code to the file level, so we can see exactly the source code of this file and exactly where is the problem reported by SonarQube. For instance, here we have an issue which is based on a broken coding rule, so you can know that this is exactly the line of code. Okay, and based on some plugins, you can see the guy that has created this broken rule. Okay, so that's not for pointing the finger, but it's good to know that this guy is going to fix it as soon as possible. So we have this very flexible source code view that you can see exactly the different issues found on this class. Now, this is not the only code viewer we have in SonarQube. We can click on different metrics. For instance, let's click on duplications, and again, moving from a drill down view. Here's another code viewer, but it's more compact, and will give you the exact number of lines and exact place in your system, but you can find these duplications. Okay, so you can easily not only know how many lines of code you have duplicated, but you know the exact code, but it's somewhere duplicated in your system. And there's a cool feature in SonarQube that you can instruct SonarQube to do a cross-project duplication. That means that it can find duplicate code across all different projects that are hosted in SonarQube. That's sometimes very important because from my experience, when you start up a new project, you usually get some piece of code from another project that you know that is working, some basic libraries or things like that, and you copy it into a new project. So if you have some tens of projects, you might end up with having the same code or slightly different code across different projects. So SonarQube can analyze this code and detect duplications across all projects. So it's a good idea to find this code and start thinking about implementing, let's say, a library, utility libraries, and remove this code from your projects. So as you can see, on the left side, you have the two classes that are involved in this duplication. Apparently, if you have more than two classes, these should be displayed here. And click on each class shows exactly the lines of code, the blocks that are associated in this duplication problem. So the last one that I would like to show you for these dashboards is that, let's click on unit testing, which is here. Yeah. And again, we dive here. So this is the third source code viewer and reports exactly about test coverage. Each line that can be executed by test has a color, red or green. Apparently, red means that has no unit test, and green means that at least one unit test executes this line of code. Okay, so you notice also that we have a line here that is, let's say, orange or yellow. I don't know how to look like. So, and we have also some numbers in another column. here, as you can see, this is a branch statement. We have two conditions. So we have 4 different ways of accessing this branch. We have 2 booleans that can have true or false. So we have 4 different branches. And this is indicated by this number. The number 1 here shows us that only one of these 4 branches is covered by test. Okay, so this is really valuable information if you want to exactly know, okay, I know that this line is executed once, but I don't know which one of the branches are actually covered by tests. And from my experience, usually developers that write unit tests tend to write tests only for the success scenario. Okay, so we ignore the other the other parts of the code, and usually most of the bugs are found on these paths, on these alternative not success scenarios. Okay, so that's a cool idea to see how you can spot specific lines of code that are not tested adequately by unit tests. Now let's go back to the project dashboard. So you can see a lot of numbers here. Okay, let's see the differential view service that I discussed previously. Here we have a list box, but provides some delta periods. A delta period is defined from, it is this customizable. You can define your own periods, or you can use the default periods provided by SonarQube. So whenever I click and I select a delta period, you can see that several things are modified in the dashboard. The first thing you notice is that for each number, we have in parentheses another number that indicates the difference between today and the selected delta period. So from the previous analysis that was run yesterday, I have created some new technical debt, and I have created some new issues. I have reduced the test coverage, meaning that my commit was not very good. So you can quickly understand, you can monitor the evolution of your code quality. And if you are take a closer look, you can see that some widgets are adding new metrics. For instance, you have this very valuable information that shows us how many test coverage we have only on new code. This is really helpful if you are dealing with legacy systems and you don't want to write tests for old code. So you can focus on this one and see how many of your new lines of code are actually covered. And similarly, we have the same information about issues. We can see the new issues created apparently from the last delta period with selected. So the last thing I would like to explain is this useful widget, which is called technical debt pyramid. And as we see, technical debt is an aggregation, a computation of all the different metrics of quality. So here, and it's expressed in working days. So in SonarQube, all rules are categorized in 8 different categories: testability, reliability, utility, usability. So by monitoring this widget, you can understand which are the most problematic areas in your system. So for this case, as you can see, the maintainability category adds 10.7 days out of 12 days. So if we, let's say, evaluate the quality of our system, we should think that maintainability is the major problem of our system. And how many days do we need to fix every problem about maintainability? It's more or less about 11 days. Okay, so that's the very cool widget about technical debt, and I'm pretty sure that managers can understand it very, very well about that. So that's about the global and project dashboards. Let's go back to the presentation and finish a couple of slides. So the big picture behind that and managing quality and technical debt is that ideally we would like to have this kind of source code every day, ideally. So that means that we can track and we try to reduce technical debt every day on an ongoing basis. Okay, I would love to cook in that kitchen and work in this kind of source code. This is ideal scenario, so try to be as close as you can on this image and not the previous one. And The other one is that all developers are responsible for their code, not only seniors or architects or whatever. Juniors feel like, okay, I'm a junior, I have my senior, he's going to correct my code. No, everyone is responsible for their code. Okay, so not only our moms are wash the dishes, everyone that produces some garbage, some litter, has to clean up the kitchen and not wait for someone else to do that for him. And finally, ideally, we would like to get notified if something goes wrong and get some alerts and do some immediate actions if something is not as our predefined quality thresholds. And to share you my dream about code quality, I know that it's not a very popular, or at least it's not a very popular topic to start implementing in development project. So I would like to see one day that code quality management systems are as essential as are today source code management systems. I mean, every software team starts by the first thing is to install and use Git or SVN or Mercurial or whatever. Okay, so I would like to see that the next step is going to be to use a code quality system like SonarQube or something else similar or even better if something exists. So I think that's enough. Thank you very much for your attention. Thank you. We have some, I think 5 minutes, we can have some questions, right? So if anything, yeah. Can you speak loudly because I can't. Custom issues, what do you mean? Yes, you can say that here I have a problem in my code and you can create a custom problem, yes. And you can describe it exactly what's the problem and people can see it and do some actions to fix it. Okay, yeah, there is a plugin that can generate a PDF report and you can have it and send it to developers. But my suggestion is not to do that. It's better to developers come and see the dashboard because it's more live. You can do some more things. A PDF report is something static. You cannot compare with the past. You cannot dive from the project level to the source code. You don't have a report with all this source code. Okay. Yes. There is a notification. Yes. I misunderstood your question. Yes, the notification mechanism with SonarQube, you can subscribe to these notifications. You can get alerts by email when you have created some issues or you have reached the quality flow. You can get email notifications. Yes. Yes. Exclude problems. Yes, of course. You can define your own rule sets. It's customizable. SonarQube comes with a predefined set of rules, but you can do whatever you want. And you can exclude rules. You can exclude files from analyzing them. It's very flexible and very customizable. It's not my product. You can visit their webpage and see there are lots of companies around Europe and US, but actually, and large companies that use SonarQube as a code quality management. There are really lots of companies. Yes. Sorry? The analysis? Okay. It's for medium-sized project is really fast. It takes no more than a couple of minutes. But for large, huge projects, at least from my experience, a project of 700,000 lines of code, it takes about 25 minutes to be analyzed. But if you had that large project, you don't analyze it every time you commit the code. Okay, you just analyze it once with your nightly build or once a day. Yes, there is a feature that you can set SonarQube to analyze only the new code. You can do that. Yes, actually there is some branching configuration, but each branch is considered as a different project on SonarQube. So you can't have any merging or but you can have two different branches as different projects on SonarQube, and you can compare if you want to see if something goes wrong. Yeah, I cannot answer this question, but I know that many people have the same problems with you. I assume and hope that something will get better about branching management in SonarQube in the future. Yeah. Exactly. Well, it depends. There's one that I think it should be placed in the core SCM activity plugin, because this is the one responsible that gives you this new code, new issues, and this is the one that provides the committer of the line of code in the source code cure. I think if there's only one plugin, this is the one that I would like to recommend. I mean, you mean if there are rules for Java 8? Yeah, they are start implementing some Java rules. There are some for lambdas and functional programming, and eventually they're going to be added more rules in the next versions.
I'm representing the project where we used about 1 year. 1 year Sonar, and it's about 50 developers, and we encountered some kind of problems. And one of them is every 5 minutes or 10 somebody push the changes, and it's quite common situation when some rules broke the build. I mean, checks not being there, so on. And then we have different approach. Fix this issue as soon as possible, relevant changes, or decreased thresholds. What is your opinion about this? What approach is the most acceptable, suitable, favorites? I don't know.
Okay, there's no silver bullet. It depends on the project you have, the skills of the developers. So my suggestion is try to have not very high thresholds. Try to begin with low thresholds so that developers get familiar themselves with these thresholds. And if you reach them, then it's a good time to think to get some higher thresholds and try to improve even more the quality. I think that's a nice solution to start working with SonarQube. Having high quality thresholds and lower them, it's not a very good practice. So you could start from a lower level and step up every time.
Okay. Have you faced some problem regarding quantity of developers regarding this one tool? I mean, it works for 5 developers or it works?
It doesn't matter. I mean, there's no limitation about how many developers work on the project. I have seen it in large companies with hundreds and developers not co-located, distributed in several areas in different places. So there's no limitation of the number of developers.
There is one single SonarQube for all company, or there are several?
You can do what you want. If you would like to spread the if you want to have one installation per team or per department, you can do that. But I think that it's better to have one installation because you can compare things, you can manage in a centralized system all the coding rules. It's better to have it in a single point of access. But you can do several installations. It's up to you.
Извините, пожалуйста, один вопрос, и мы out of time.
Okay. No other questions. Oh, again.
Which type of database is used?
You can select anyone you would like, Postgres, MySQL, Oracle.
Is it easy to install it? Or?
Yeah, it's really easy. Yeah, actually, SonarQube doesn't do anything with testing. It expects to find in a predefined directory position a file that describes the results of the test that you have already run before SonarQube. So if this format is supported by SonarQube, then it's going to display this information. If it's not supported, then it probably won't give you any information. But it doesn't compute any test coverage or test information by itself. It expects to find a file generated by another tool, for example, Cobertura, Jaco or whatever. It's your.
Generate some reports like Cobertura, but currently I can integrate it in my SonarQube. Is it will be to implement in the future or just?
I think that Cobertura is well integrated with SonarQube. We can discuss it later if you want. It's very specific. But there's also documentation very well explained how you can do that.
Ну, давайте поблагодарим нашего гостя.
Thank you very much.